Hi class. So up to now we've been separating charges and creating potential differences mostly by mechanical means like friction. We've been putting electric charge in some conductors and then the other conductor became positively charged and then we had kind of a capacitor which we connected together and created a current. So this is all nice and well, but it's not very steady and it's a lot of work and this is not how we generate electricity. So let's look at other ways to generate electricity and what is up with all that noise? Yeah, what are you up to?
I'm trying to power up a light bulb.
Okay, it looks like a lot of work. First of all, incandescent light bulb, this is like so passé. Nowadays, look, this is an LED. Ain't that easier?
Oh yeah, that's also much brighter.
Yeah, a little too bright. But also, why are you like doing this mechanically? Don't you just have like a battery or something?
I don't have any.
You don't have batteries? Okay, well, oh look, I think we can create a battery. Look at this. Do you know what this is?
Probably copper and zinc.
You're right. It's exactly copper and zinc. Very good. Yeah, you know your metals. So copper and zinc, and I know almost nothing from chemistry, but I do know that if there's some kind of acid here, there'll be a chemical reaction and we'll have a battery. And remember, you don't need to know chemical reaction, but the basic idea of a battery is that there is some electrolyte, which we don't have right now, that's going to move ions, kind of an escalator, the charge escalator. It's going to move it from some negative plates, it's going to become negative because ions are moving away from it, to some positive plates. Okay? So let's try that. So I have these two here right now. Without any electrolyte, the voltage is like something very small and fluctuating in millivolt. 14 and blah, blah, blah. Millivolts 10 to minus 3 volts. So this is really small. So let's put some electrolyte. Mountain Dew, you know? Yeah, that's acidic. Like So and I pour it in here. This is my nice Mountain Dew, and let's see how it does for a battery. Great, now this is in volt.
Oh wow.
And it's about 0.996. We have a 1 volt battery right there. Isn't that nice?
Yeah, that's nice and all, but it's not gonna last forever.
Okay, yeah, that's true. So what happens is that there's a chemical reaction and it brings ions from, disintegrating the zinc pretty much, putting them on the copper, and it goes on until you get 1 volt and then it stops. So that's true, it will stop there.
The chemical reaction is going to build up the potential to 1 volt, but if you connect that to an external circuit that's going to drain the current, then the potential is going to go down, but then the chemical reaction will bring the potential up to 1 volt again, and that's going to use up the acid in the Mountain Dew.
That's right. You're saying, yeah, okay, so if I connect this to a circuit element, I'm going to draw current.
Yes.
And then the chemical reaction will restart to keep the potential difference to 1 volt.
That's right.
Right, so this battery is always 1 volt until I run out of acids if I connect the copper atoms. That's good. But unfortunately, this particular battery would not work really well. It's not well designed. It's just a Mountain Dew in a bucket. So, but this is the basic principle for other batteries. See, I have my own batteries. And these essentially are, again, two metals with some acid in it, and you can get voltage. And look at this, for example. This is a 1.5 volt battery. This is a 1 volt battery. This one is better made so that I can draw a large current from it, and I can make things turn, for example, like this little motor. Isn't that much easier than cranking like you were doing?
Surely is.
All right, that's a battery for you.